couple of quick problems. Let's take a look at 7b first. Y equal x minus 5. Well, I'm going to set y equal to lambda and x minus 5 equal to lambda. Take a moment, write that down. And we're going to turn this into a vector form. Vector form looks like this. Who was the center of the universe in here? Oh, Abby was. Did somebody say Brady? Oh, that's funny. But anyway, if you look at the vector form, the center of the universe was Abby, and she was at the origin, 0, 0. And then we found a point, x0, y0. This is a point that's on this line, and we're describing this line with vectors. So we've got to start from the origin, get to the line. That's what this point was for. And then we went a number of steps, lambda, in a direction AB. So the direction AB gets me going this way and not out off to the side. And so any point on that line can be found by going center of the universe, AB, to a point on the line, plus steps in a direction AB. That'll give you every point on the line. So we got to turn it into that format. To do that, what I'm going to do is I'm going to move this 5 over to this side, 5 plus lambda, and I'm going to move the lambda over 0 plus lambda like that. So now you can kind of see, oh, there's the xy. Oh, there's the point. Here's lambda. Oh, 1, 1. There's the direction. So that line, y equal x minus 5, can be turned into this vector form. Notice that this is parametric. This is parametric. And this guy is your vector form. That's pretty cool. You try number per part A. All right, so we're going to take a word problem, break it into different components, and see how these skills we've learned about vectors fit. In this question, distance is in meters, time is in seconds or minutes. 2 model airplanes are flying. Now these are flying in space, so they can have an XYZ component. The first airplane is at point 327. Okay, so this is the start point. This is from Abby to a point on the path of the plane. This 3, 4, 10 is the direction vector, which helps us to find the speed. And we said this yesterday, if this is distance is equal to distance plus distance, and time is involved, time times speed gives me distance. So that makes sense. Okay? So we want to find in part A the speed of the airplane. The speed is going to be the square root, or the magnitude, of 3, 4, 10. And that is, what is that? What is that? Square root of 125? Does that sound right? Yeah. Square root of 125 meters per minute. Don't forget your units there. You don't need to calculate that unless you want to. At 1,300 hours a second, the same time as this one, a second plane moves from this starting point. So this is their starting point. And it's moving for 2 minutes. And after 2 minutes, it gets to the point 316, 19. Show that this position vector is correct. So in other words, in t equal to 2, we want xyz to be 3, 16, 39. Well, let's see if this works. 5, 10, 23. T is 2 times 4, 3, 8. So you go ahead and see if that's true. Did it work? Is 3 equal to negative 5 plus 2 times 4 is 8? Does that work? Yep. is 16 equal to 10 plus 6? Oh yeah. And then of course 39. 39 is equal to 23 plus 16. And that's true. All true. So that it works. Next, show that its position. Okay, we did that. The airplanes meet at point Q. What time do they meet and what's their position? So I'm going to erase this so we have some space here. You think about these two equations. At what time do the airplanes meet? If we're meeting, what will be true of their x's? Yeah, x will be equal to x, right? If they meet, x will be equal to x. So x is going to be 3 plus, is that 3t? 3t. And this one, x is equal to negative 5 plus 4t. Okay, so if we subtract 3t to both sides, I get 3 is equal to negative 5 plus t, and if I add 5 to both sides, I'm going to get t equal to what? 8. Yeah. Let's try y. Go ahead, Drew, why don't you try y? For the y equal y, we have 2 plus 4t equal 10 plus 3t. So if I subtract 3t to both sides, I'm going to get 2 plus t equal to 10. T is going to be equal to 10 minus 2, which is 8. Did t equal to 8 for the z's as well? Yay! So therefore we know the time when they meet is t equal to 8. Now let me warn you, this is if you know they meet. If you're not sure if they meet, then you need to call this t1 and t2. And you have to do like we did with lambda and mu and solve for those, because they may not meet. These x's might meet in one place and the lambdas meet in another place. So just be aware that since they're saying they meet, we set t equal to t, but they don't have to be that way. Now to find the position, all you have to do is t is 8. It's a parametric equation. X is equal to 3 plus 8 times 3. Y is equal to 2 plus 8 times 4. And Z is equal to 7 plus 8 times 10. And that's going to give you 27. This is going to give you 34. This is going to give you 87. Right? So the position of this Q, point of intersection, will be 27, 34, 87. That's the point. Now would that work for this one? Let's see. Negative 5 plus 32 is 27. 10 plus 24 is 34. 23 plus 64 is 87. So that works too. So that definitely is where they meet at t equal to 8. Then the last one, find the angle between the paths. The angle between the paths is a formula that has two vectors in it. Cosine of theta is vector A dot vector B over the magnitude of A times over the magnitude of B. Now what you have to do is to find out where the direction paths are. So I'm going to take this highlighter, and is this green or blue the direction vector? What's that? Why is it blue?
Blue.
But why is that? That's great. So why 3, 4, 10? Why is 3, 4, 10 the direction vector and not 3, 2, 7?
Because we have to know after a certain number of steps where...
This tells you the direction, this tells you the steps. So this is not a position, this is a speed in a certain direction. This is a point. So a direction, it's a location. So if we're looking for the direction paths, it's going to be whatever's next to this lambda or this t. So A is going to be 3, 4, 10. And then what will B become? Which one will it be? The negative 5, 10, 23, or 4, 3, 8? For this one. 4, 3, 8. Isn't that easy? That's the direction vector. Then it's going to be the magnitude of 3 squared plus 4 squared plus 10 squared times magnitude of this one, 4 squared plus 3 squared plus 8 squared. And I'm running out of room here. So the cosine of theta, they're going to multiply across and then add. So this is going to be 12 plus 12 plus 80. And then below here is the square root of 125. This is going to be 64 plus 25 is the square root of 89. So I'm going to need your help. What is the inverse cosine of 104 over root of 125 over root of 89? Decimal for me, cosine of theta equals point what? You get 0.986? Yeah. And so in degree mode, let's find out how many degrees this is. Do the inverse cosine, the undoing cosine of 0.986. That should be, what do you get for degrees? 9.6 degrees. That's great. That's the angle of the two paths. So what we did is we went back to the vector form and we picked the directions and we said, oh, this is the direction vector A, this is direction vector B, and we just slammed it into this formula. You don't have to memorize this on a test, it'll be there for you. It's the dot product over the magnitude over the magnitude. Dot product, you take the 2, the x1, x2 plus y1, y2 plus z1, z2. We proved it in class. This is the square root of all of those. So there's a nice word problem for tomorrow. For homework, you're going to do number 7 here. And it has 6 parts, but it's super doable. Good luck.